How we doing, y'all? So my name is Wilson Tomhave. This is the Buddy Hall Top Fuel Machine. So we are a top fuel machine, very local in the area in Dallas. As you can see, we are a very high power machine. This is a nitro top fuel racing car. So right here we have an about 11 to 12,000 horsepower vehicle. It goes up to about 323 miles per hour at the step, and it's a 3.69 second car. So that's in an eighth of a mile track. So at the 60 mile, or not 60 mile, but 60 foot mark, it's about 150. It's a lot right now, but as you can see, the car itself is a John Force head block with John Force heads on it, and it's a very high power car. So this is a 6-blade clutch disc. So this helps the car go what it needs to do, and it has little fingers in there. This is called the cannon, the outside of it, but inside has a bunch of fingers and clutch discs to help the car move what it needs to do. This is called the puke tank. So this carries and collects all of the oil and all the little debris that you get in the engine, and it ends up into here. So that's why it's called the puke tank. But what we have here is the chutes for the car. This is what slows the car down. Everybody thinks that it's a brake. It's really not. This is called the chutes. So it's not packed up right now, but you would see a spring and a bunch of other like parachutes in here. So there's one big giant spring that springs out. The driver has these cords right here come on the inside, and they loop into right here, and there's like a little wire right here that the driver has up in the cockpit. We'll show you that here in a minute. But there's a little string that the driver kind of pushes down. The string comes out, and that's what makes the spring come out. And that's what slows the car down. Necessarily doesn't need a brake, but that's what we have just as a precaution. The wing helps the car to kind of have the downforce of it, so the driver can be very, very safe and it doesn't catch up into the wind. But this big wing helps the car stay on the ground and stay level with it. And you would also see back here a wheelie bar that also helps the car, so it's raised up on the ground about that much. Keeps the car very level with it. Just make sure that the car is very level. It just stays where it's supposed to be, doesn't go anywhere else with it. So the tires themselves are about 114 in circumference. I put about 10 pounds in them today just to show everybody how big they are. But usually I'll put about 5 pounds in them to 6 pounds, depending upon how much the track is, temperature-wise. It's all adjusting accordingly. Whatever the tune is, I want to make sure there's less tire pressure in here, because when you get on the track, you want to make sure that these have enough grip to go, because the engine itself and the clutch and the tune needs very precision things. This needs to be at its max. So it's about 5 pounds and about 115 in diameter or circumference. And when you put 5 pounds in it, it actually rolls on top of it itself. It folds. It's weird. It's really cool though. But so we're coming to the front of the car. You know, we have the cockpit right here for the driver himself, and in front we have the computer. And so what we were talking about a little bit ago with the parachutes, these are the wires that go all the way back to the parachutes. So when these are up, the driver at the end of the race puts these forward and the chutes come out. Now here's the brake along with it as well, but we hardly use that. Here's the steering wheel, and here's the monitor to see how much RPMs, how much fuel, just to make sure that everything is accordingly. And here's the computer system's here as well. This is the actual kind of flipping the buttons for the car, kind of turns it on, make sure the switches are on, make sure the computer is on, everything electronically is on. But to go back to the driver a little bit, we want to make sure as crew members and to make sure that he is as safe as possible. So these are the actual keys to the car. Not a lot of people know that, don't see it, but these are the keys to the car. So as soon as these are out, we cannot turn the car off unless the computer says it. So when these come out, the car stays on. We try to keep those on when we do a warm-up in the pit and make sure that everybody's safe and those are safe in there. But we have this thing, it's called the starter. It's a big motor thing. It connects to 2 batteries over here, and it actually jump starts the car, if you will. So it's a big motor thing, locks into these here. You shift it and it locks into about right here. And then it's got these teeth, you wound it up into here, and make sure, you see it move just a little bit, that's what the teeth are doing. So it locks in there, and then there's the buttons that turn it on, the batteries hook up to it, you turn it on, and then it jolts to life. So at that point it's running on its own, the keys are still in it, make sure that it stays there, but the fuel's going through. We probably put about 5 gallons, maybe 10 gallons in it just to warm it up and to make the computer understand it's on and to get as much data as possible. Because when the computer's on, it's talking to us and it's telling us, okay, this piston right here, piston number 2, may not be firing all the way. That's what this is. So this hooks up to the computer system right here. It may tell us that piston number 2 is not firing, or piston 8 is misfiring and it needs a little bit of extra or something. We don't know what exactly is. That's why we have a computer in the system. It just helps us further along the technology and helps us to understand what these things are thinking. Along the way, it just helps, and the computer's here, and so that's why we have a tuner. The tuner makes sure that the driver and the engine itself is doing what it's supposed to be doing. Not to say that people do it wrong, but that's where the human effect, we're all humans, we make mistakes. So the tuner is to make sure that the computer corrects those mistakes and make sure that we can just further better ourselves in this field as a competitor with John Force Racing, Tony Schumacher, and a bunch of the big name brands out there, just to make sure. So our biggest sponsor of the year is Methanol Moonshine. You know, at the end of the year, we're hopefully, when we win a Wally at the end of the year, which is the big trophy, we will be celebrating with moonshine, and hopefully in Ennis, when we race in Ennis, we'll be putting 5 bottles of our methanol moonshine in the tank. Because the car itself is, you know, a couple gallons and a couple percent of alcohol anyway. You know, it's 10% nitro and 90% alcohol. It's a bomb. It's basically a bomb. But coming to the front of it, everything that you see here is all hollow. There's nothing here. It's very open and it's just a skeleton at this point. So the car is easily, you can see how long it is. The car itself is 27 feet long, and right here in the middle is where it's the most dangerous. If you look up videos, you can see that the car is actually bending. It like moves throughout the whole race. In the 3 seconds that it's going down the track, it moves. It moves. It's really cool, but scary at the same time, of course. But nonetheless, we have a 22-gallon tank like what we were saying earlier. It is up here. The driver himself mixes the fuel himself, make sure that everything is up to standard, make sure we have a 10 to about an 80 ratio of alcohol and nitro, which is in the car. And then this little number right here, not a lot of people know it, but it's just a flashy thing. But this thing right here, when he goes down the track, air sucks through here, or doesn't really suck, it just is pushed through here and then shoots the fuel, the 22 gallons of fuel, all the way back to the engine. So it doesn't need a motor to pump all the fuel to the back of the car. That is just a little bit of that. It's not really a whole lot, not a whole lot of science to it, but to be quite honest with you, that is why we have a 22-gallon tank. Not everybody has that. They have a really small tank, but it's just added weight to it. Everybody needs weight in the front. That's why we have the wing here to make sure that the downforce of the car is staying with it. But it's just another piece to the puzzle that makes the car does what it's supposed to. This is all carbon fiber, so it's really lightweight. Make sure the wind goes up and over the car to the top of the wing to better itself to go down the track, make sure it runs smoother down the track. That's what they're there for, is to make it go smoother and make sure the wind goes up and to the top there, so it goes over the driver, over the blower hat, to the top wing, and it's just enough to keep the car settled and on the ground. Because this thing is basically jet coming off. If it had wings, it would probably take off. You know, the car itself was going at 5 to 6 Gs. You know, that's what fighter pilot jets do in the Navy. This is on ground. But that is Buddy Hole Racing. Thank you very much and have a great day.